Yeah, something ridiculously small, yeah.
Yeah, and as DJ was saying, we can demonstrate the whole ships over the horizon, things being cut out bottom first. We can demonstrate that on known flat surfaces. The whole argument behind the globe is, oh, the ship sails away. I don't see the bottom. It gets cut off first, and then the top, et cetera, et cetera. That can only happen on a curved surface. So the Earth's a globe. It's not true. We can demonstrate it. And we don't need math. We don't need an explanation. We can take a surface that we know is 100%. This surface is flat. We can replicate it. We don't need to know why. We don't need to know how because we can just replicate it. So the scenario of impossible on a flat surface is not true. The question of existence or non-existence, not whether, you know, why or how or who or what or when. Is it or is it not? It's that simple.
Yeah, bare minimum, anything that they're going to cite is going to be at least a kinematic equivalence. We all know there's zero exclusive proof for a globe. Why we exist.
All right, Tenori, are you done playing Pokemon now? Can we finally get your Glober take?
Pokemon. Come on, man.
Yeah, he was playing Pokemon Rangers.
Pikachu, I choose you.
No, I'm not clip farming you. I just want to know. We want to hear you. We want to hear your proof. All right. Well, if Shinori's not here, Shane, are you still there, or are you gone now?
I'm here.
What do you think of Indio's? What do you think of Indio's arguments or his response to you?
And I didn't hear for me. I didn't hear anything that was compelling and forcing me into yes or nos when they're not definitive things. Doesn't really. It doesn't continue the conversation.
Well,
So
I
I
just
didn't really have a
demonstrated that the
response.
math does
My
not work.
allowed response was yes or no.
Well, I demonstrated the math does not match the globe.
To your satisfaction, correct.
We mean to my satisfaction.
I'm giving you a response. You wanted one. That's the only one I can give
What
you.
do you mean by no? And I'm asking you, what do you mean by that?
You're satisfied with the information you provided, providing enough information for me to make a decision, correct?
I provided evidence that the math does not match the globe. That's indisputable.
But I am in dispute of it.
Okay, what part is disputable? Calculation wrong?
Is there?
Or the
I
distance is
don't.
wrong?
No, I'm just trying to figure out like is repetition the only method to have a conversation? It's boring to just sit there and repeat the same thing to each other over and over again.
Yeah, and meta's boring too when you don't actually have any answers.
No, but I answered. That's what I'm talking about. Is I
You
gave you an answer.
answered with no
You keep
substance.
asking me the same question, and then what do you want me to
No,
do?
I
Just
asked
keep
you for
repeating the answer to
specifics.
you?
I'm asking for specifics instead of weaselly like generalities.
What generality did I give you? Or what? Where did I do that? I gave
To
you
your
specifics.
satisfaction. And then I asked you, you said, well, and then I asked you specifically, what are your objections to what I showed you? And you don't have anything specific. You're just saying, nuh-uh.
I didn't say nuh-uh. Never did. Never did say
Yeah,
that.
effectively, that's what you're saying.
Nope, I answered your questions, and then you repeated the same question to me again,
You
and
didn't
I
answer the question
got it.
about specifically what was the objection. Specifically.
Which one do you wanna do this time? Are we doing a new one? Are we doing a different one? Which one do you wanna do?
Oh my God, we're gonna do what I'm talking about.
Which
You're a
one are you
snake,
talking
dude.
about?
People like you
Which one?
fucking piss me off. You're a
Okay.
fucking weasel.
So you want me to give you specifics, but you don't wanna give me an example.
I already gave you an example. I
Which
said, hey, I
one?
presented evidence that proved
Which
that the Earth's not that proves that the globe math isn't actually observed. You said to your satisfaction, and I said, well, it's objectively true that that happened. And then you're like, well, there's problems with it. Okay, specifically, what's the problem with what I showed you? Oil rigs. What's the problem with that? 8-foot observer height. Oil rigs 30 miles or 10 miles away. Horizon distance is predicted to be 3.46 miles away. Horizon is beyond the oil rig. There's nothing, everything I just said is objectively true. So which part of those do you object to? Which one? Is it the horizon distance? Is it the observer height? Is it the distance of the oil rigs? Which one?
Are we
It's
using
easy.
the Go ahead.
It's easy to calculate the horizon distance for the globe. 1.22 miles times the square root of the observer's height in feet. That's what the globe prediction is. 8 feet, easy to calculate. It's 3.46 miles. These rigs are 10 miles from the camera. The horizon is behind the rigs. If the horizon is behind the rigs, that means it's further away than the rigs are. Farther than 10 miles. 10 miles is a greater number than 3.46 miles. I can't take you seriously, dude. You're not a serious person. You're just trolling. Doing the frustrator troll. What else is new?
All right, Tenori, are you there now? Get off Pokemon Go and come back. Let's see who else. Tristan. Oh no, is Tristan a flat earther or is he a globe earther? Tristan, you're a globe earther.
He thinks it's a globe.
Okay. All right, Tristan. Tristan, you're up. Well, all right, Shane. Shane, you're the Shane. Shane, you're the only one. You're the last one standing. No one else is. Shane is the last. He's the last Spartan alive for the globe. You're the last. You're the last man standing. Okay, so yeah, so let's get back to the horizon thing. So why? So the horizon's supposed to be closer, but it's further away, right? Do you agree with the premise that the horizon is supposed to be at 3.8 whatever miles that he said? Do you agree with that premise, Shane?
Yeah, that's like Ryzen would be at like 3.8 miles, somewhere around there, if an 8-foot observer.
Okay. So you agree that it should be at 3.8 miles, right? Okay. Okay, now in the actual photograph, it is not there, correct?
Mhm.
Do you agree that it's not at that distance?
Yes, I agree that the perceivable horizon is not at that distance.
Okay. So why isn't it there? Why isn't it there? It should be there, but it's not there according to the globe. So why not? Why isn't it there? Shane.
So in your earlier video that you put, let me see, where you can see the refraction changes and the horizon moves.
It's refraction. That's the reason?
Sorry, I get easily distracted by things like that. For a moment, I actually like opened up my mind to, hey,
Yeah.
what's the first thing I'm gonna say? Sorry.
Okay, the
So it's
reason is
just
refraction, right?
I'm sorry, what was that?
So the reason is because of refraction. That's the reason, correct?
That's why that perception of it is moving up and down.
Okay, so that
Very similar
is
to at 38 minutes past the hour. Shut them
so
down,
that's
post it.
7 miles. Well, just to be clear, if it's appearing at 3.8 and it's their actual horizon is seen beyond 8 mile or beyond 10 miles, right? So that's 7 miles of refraction. So you believe the light is there's 7 miles worth of refraction there. That's what you believe. Correct? Shane.
I would say I don't, let's say the refraction is 7 miles long. I would say that the like the view that it's giving you. So very similar to like at 38 minutes past the hour, that shut him down posted, where he posted a GIF of atmospheric refraction. Would you say that horizon is suddenly farther back than what it
38. Sorry, go ahead. Say again.
No, it's
38
not.
minutes past the hour? Unless it's,
No,
38 minutes past
not.
the hour.
It's
But it
not
shut him down.
changing distance. It's not changing
No,
distance.
I'd be saying the horizon is what? Did you say moving? Not moving?
No,
So you've got
I
a
didn't
problem,
think that.
Shane. You're trying to prove this is what you're doing to us. Other than dodging questions, and we can all hear it, it just sticks out like dog's balls. You are trying to tell us that curvature is actually refraction. That's what you're now selling us.
Did I even closely allude to that? I
Yes,
didn't.
well, I do apologise, but that's exactly what comes out. You might be seeing
That's what
one thing,
that's what
but
you
the
heard
words
from.
that are coming out that have been translated, you are now selling us curvature is refraction. So you need refraction to prove curvature. So how is refraction related to curvature? It's not.
So you took something that I did not say and told me that I
No,
needed that to do
that's
something,
you
and then you
need. That's what you're
asked me,
selling.
okay?
That's exactly what you're selling. You're telling us about these refraction and disturbances and mirages and all that shit. You're supposed to be proving curvature, not light effects.
That's crazy. 7 miles. Wait, so Shane, do you honestly think it's refracting 7 miles? Like honestly. There's no way. That's insane. So that
I don't think
doesn't
it's refracting 7 miles, but I think that is just like at 38 minutes past the hour that shut them down, put down there. I don't think that horizon is actually moving farther back. I don't think it's like
so
shifting that horizon and making it a different, like moving what you see as, extra miles behind it.
Right, but the physical
If you
geometric
will allow you to
horizon.
see some of that,
That
but
doesn't
it
make
doesn't
sense.
mean that the
Dude,
horizon that we would do mathematically
listen.
is
The
going to make that leap.
horizon,
Sorry, DJ.
the physical geometric horizon should be at 3.46 miles. It has to be there, like the physical geometric horizon, like in front of the first oil platform, halfway to the first oil platform, basically. But we can see the horizon's actually like way, 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 way beyond the 10-mile platform. In the GIF that Sheepdog that shut him down posted, right? All we see happening is like towering and stooping effects where it's just jumping up and down, and also the tide's going up and down as well because it's a long time period time lapse. So we don't see the horizon all of a sudden appearing behind an object and then in front of an object like we see in like we don't see in this observation that we presented, because the physical geometric horizon would have to be at 3.46 miles, right? So what you'd have to be saying is happening here is really there is a horizon there at 3.46 miles, but it's impossible to be seen, and then everything beyond that is just an illusion, right? Everything beyond that is really hidden behind the curvature of the Earth. Like all of that water is hidden behind the curvature of the Earth, but refraction's lifting it all up different heights to make it look like it's flat. It's not a claim that has any evidence to back it. Like if you were to say that there's all of that water is actually hidden behind the horizon, right? So the bottom 30 feet of the windmill, the bottom 30 feet of the oil platform should be hidden as well, physically. Like you would have to say that that's all just an illusion. Like everything would have to be lifted up at a different height for it to look flat. Does that make sense? Like at 10 miles, it would have to be lifted up 66 feet. And every distance in between would have to be a different amount that it would be lifted up. And then it all just happens to look flat. And then we do it in different weather conditions, and the same thing happens. And then we do it hundreds of times, and the same thing happens every time in completely different weather conditions. It's not a good excuse to say it's refraction. It doesn't hold any weight.
Shane, did you understand what he just said? Do you understand any of that what he just said?
I understand words.
So would you be able to let me ask you this way. Can you steel man what he said?
Because this is on YouTube, I have no interest in doing that.
So the correct
Okay.
answer is no then.
Okay, it's
Yeah, I
fine.
could say no.
Okay.
No, I have no interest in doing that in this scenario.
Okay, so you brought up Shut 'em Down's GIF, and there is nothing in the GIF. It does not show that there is an object that was once hidden that is now visible because of refraction, right? Agree?
Yeah, it's not focused on any specific like landmark or anything like that that would be in front of the horizon or would be pushed into being in view.
Okay, so
I
it
mean,
would
unless you're
not.
looking at the distant stuff, but that doesn't really help much.
Is there any? Let me ask you this: is there anything in that GIF that Shut 'em Down posted that would indicate that 7 miles worth of refraction is possible?
7 miles of refraction is possible.
Yeah, like something appearing at 7 miles where it should not be. In other words, where you see something, it's 7 miles, but it should not be there, right? It should be 7 miles away or 7 miles closer. Should be something that's far away that should be 7 miles closer to you. Do you think does that GIF show you that that is possible?
I mean, I could draw that inference, but I don't see any data on it. But let's say that the landmarks behind it, the sorry, landmarks off in the distance, are they becoming in view because of atmospheric refraction, or is it the inverse is occurring? That I don't know. Like which part is the atmospheric refraction? The beginning of the video, the middle, the end, the whole thing?
I see what you mean. I see what you're saying. So the land obviously is not constantly moving up and down. Like not the water, but you see like the land behind it, the shoreline. It's not it's in reality it's not constantly being moved up or down, right?
Like in reality, no. In the view, it is moving up and down a little bit, but yeah, not in the in reality. There's no earthquake or bulge or anything happening there on it.
Right.
It's not floating. I
But
don't think.
do you think that the fact that the view is changing would make it possible for something to appear 7 miles away from where it should be, from where it actually is?
And it, definitely possible.
You said so a little bit. What? How? Can you? Are you sure about that? Like 100% sure?
And if I understood your question correctly, and I understood the conversation that we were just having uh, around like that very specific image at 9:38 p.m. from Shut 'Em Down, uh, and my statements of I can't tell if the atmospheric refraction is what's allowing us to see the landmark behind, or if it is obscuring it. I'm not sure what this image is showing. So, um, would
I
I be
can
able to
tell
see
you.
farther with atmospheric refraction, or would I be able to see farther without it? That
Heavy
I'm
refraction. Heavy
uh,
refraction's very destructive.
yeah, zero point 0.5 and above is yeah, does some crazy stuff.
Right.
How
So
many
the
miles do
refraction.
you think?
Oh, one
Let me.
second.
Can
One
you?
second.
Go ahead. Yeah.
One
Go ahead.
second.
Yeah.
Yeah. Sorry.
Mhm.
Sorry. Just because he said above 0.5 is very destructive. So um, we need way above 0.5 to have no hidden height on these on a globe. Mostly for most of these, we have to max out the refraction slider, put it up to full, which is so much refraction that the Earth would just look flat, according to Walter Bislin, who makes the advanced refraction calculator.
Inversion happens at 0.5.
Okay.
So
Can I just ask a really quick question? I just want to make sure you're being honest here. Okay, Shane.
Mhm.
Can you see around a corner, 90 degrees corner, with your own
Like
eyes? Can you see around a 90-degree corner?
like walking through my house or something? No.
Yes. Okay. Why can't? Okay. The answer is no, and I agree with you. So why can't you use refraction to see around it?
Why? I guess the question I would have is why couldn't you? Because like to me that seems obvious.
So you think you can? So why? So why'd you say no then? Why'd you say you can't see around it?
Inside of my house currently has no refraction that I can see.
So the answer is no. So refraction does not allow you to see around it.
Is that what I said?
You
The in
said
my
you
house
could
right
not see
now,
it.
in
So
my
you
house
can't
right
see
now,
around a corner. Why not? I thought
in
you.
my house
What happened to refraction? Why can't you use it?
right now, there's no refraction inside of my house. There's not a huge amount of humidity or
How do
heat
you know?
changes or anything inside of my
How,
home.
wait, how do you know?
I mean, I have
Hold on.
multiple ways of just measuring it
Just
as
for,
well. If I
I feel like we're stuck on something, and I want to,
yeah.
for the sake of
Yeah,
advancing,
this
I
is
want to,
silly.
I want to say this, okay? So
Mhm.
we, as flat earthers, can demonstrate. We have other people that give the demonstration for us. We can demonstrate bottom up obstruction on a flat surface
Mhm.
using refractive conditions, atmospheric conditions that create lensing effects that cause bottom up obstruction um, in the path of the observation. What we don't have are any observations of being able to see around a curve or around a hard corner or anything like that. So, what we're asking for is a demonstration of being able to see behind a hill of something, and then the horizon being behind that thing that we can see behind.
How do you guys feel about the longest photo ever taken? Or at least
Canada.
there's actually
What's
one a
wrong
little
with
bit
it?
longer, but the Fenestres to Gaspard.
Yeah, Canada. Yeah.
Yeah, you guys feel okay? That's a good
Look,
photo.
I have a really good example of one of those, like an extremely good one that's 255 miles, but it's done in infrared, and it's really really high resolution, and it's taken from the peak of Canigou. So the camera height is 9,136 feet, and he's looking out over towards the French Alps, and he can see everything. It's the craziest picture. I'll grab it in a second. So basically, the geometric horizon should be at 117 miles, and even if you add standard refraction in, it makes it 125 miles. Now, it's nowhere to be seen, right? That horizon's absolutely nowhere to be seen, and we can just see unobstructed terrain all the way basically to hundreds of miles away. So I'll grab the picture. It's a
Cool.
really good one. 1 second. So this is not done by a flat earther either. It's a professional photographer. I forget what his name is.
Let me see coloration.
So for that just while I'm pulling this up, I think from memory, the refraction coefficient you would need for that 8 foot one, that 8 foot height one, that's uh, at least 0.7 something, and we don't see any distortion at all. We don't see any miraging effects or anything. All right, here we go. All right, so I got a whole bunch of stuff to go along with this. All right, so, oh shit, hold on.
If you have like a link to like the photographer's post on it or something like that, that'd be good too.
Yeah, I do have that. All right, so yeah, this is a pretty high resolution image, so you can zoom in on it. But what I'll do is I'll show you exactly where the geometric horizon should be, like a top view.
That's a cool photo.
Yeah, this is just a portion of the photo. The entire photo's insane. It's huge. It's it's about 10 times this. It's like a whole panorama. All right, so this yellow line, that's where the horizon should be. So the horizon should be before the water ends, basically.
Yeah.
Right, but we don't see it there. Right, that's even with refraction included as a bonus.
But I mean, we are just for me to check here. We are making the statement that the things that are above the horizon are that have high elevation would be viewable above horizon, right?
Yeah,
Okay.
everything. So the horizon should be at 125 miles, which is where the yellow circle is.
Mhm.
So if you zoom in on the picture, you can actually see the shoreline. You can see all sorts of different things that you shouldn't be able to see. There's yeah, you can see the shoreline very clearly, and you can see things that yeah. Let me give you an example, right? So there's landmarks along the shoreline that we can see, right? Like there's some windmill farms that are only a few feet above the sea level that we can see the entirety of. So I'll post you the link for the website that this is from. Right, so this is a windmill farm. I think it's 25 windmills, giant windmill towers, like the ones we were looking at the other day. Right, but you shouldn't be able to see most of the windmill towers. They should be behind the horizon.
I want to reverse image search on this first one you gave me. One, because it's a cool image, and two, because I want to find the information about observer height and the other information about it.
Yeah, so it's taken from the summit of Canigou. So I'll post the link now. Just a second. So in the article, it says that he took it from the summit of Canigou, and if you look that up, it's 9,136 feet.
Okay. 9,136 feet, and then he also has some height to him, right? Just so we're being fair with each other. Let's say he's just like 5 feet above that.
Sure.
So 9,141 feet. Okay. And then the distance of this photo is
We can see mountains that
oh, there you
range.
go. The link. My bad. I didn't see you posted a link. I'm pulling that up now.
Yeah.
It's 252 kilometers at 230 photography.
So this is basically a geometric horizon test, because that geometric horizon would have to be there if the Earth's a globe. It gets a little bit difficult, right? So we can see miles that are 255 miles away in this, but it gets difficult because they have terrain in front of them as well. So it's like we shouldn't be able to see a lot of the mountains, but it's difficult to gauge exact specifics about how much of the mountain you can see.
Yeah, and some of these points are off of the like he's pointing where something would be, right, as opposed to where it is. Or am I misinterpreting that?
No. Every of those
Every one
sticks
of the
that you
viewable
can see
peak.
with the name, it points to a mountain that's directly underneath that you can see.
Okay. Is there one of these mountains that you would like from max distance? Is this max distance to pick Gaspard?
It's one of the max distances.
Okay.
I have a spreadsheet that shows you. I have a spreadsheet here that shows you the exact hidden height and the exact distance to every single mountain that you can see. It's just a second. I'll share it. Someone's gone to a hell of a lot of effort to make this.
I thought you did, man. I was pretty impressed.
No,
That's crazy.
this is we've been compiling all of this stuff, but this is an older argument. This is an older observation. I think it was done in 2019 or something like that. All right, so this is a Google Docs, and it's got every single distance to every single mountain that you can see, and then how much should be hidden of it behind the horizon, how much should be visible, and this is also including 7/6R, which is some bullshit globe refraction that people claim that they don't have any evidence for, but we're just going to throw that in for you because we got a lot of room to play with.
What is 7/6R?
It means that, to simplify it, it just means that the radius of the globe would be a bit bigger by 16%, approximately 16.67% or something like that. So the horizon would be 16% further away due to the light bending down a certain amount. Even though there's no evidence that that's happening, that's what some flat Earth debunkers like to claim. It gives them a little bit more wiggle room to try to, compensate for why we can never find any curvature. Flattens out the globe a tiny little bit by like 16%.
VAA3.
So basically, if the Earth's a globe, and if you have this standard refraction that some globe Earthers claim, then the horizon would have to be at 125 miles, which is shown on that other map with the round red circle, but it's not there in reality.
Just lost my math.
Yo.
Yo, it's good.
A lot of people in here, man. I don't hear no discussion. Anything new
Yeah.
going on?
Oh yeah, we're in the middle of a discussion at the moment. I think the Shane's doing some mathematics to try to see if this observation fits the globe. So if you have a look in the
Ah,
if you
nice.
have a look in if you have a look in the voice text, you'll see a really nice observation that was done. Maybe you've seen it before. In infrared, Mount
Um,
Canigou to the French Alps,
oh
255
yeah,
miles.
definitely seen it. Yep.
It's a good one, man.
I don't see it in the text though.
Well, look at the voice stream text. It's like a main text channel. Just above where you click into the live stream, it says
Oh,
live
there.
stream voice text.
Gotcha. Yep, gotcha. Nice. Gotcha. Thanks, shut him down. Yeah. Well, is who is the person that's doing the numbers on it?
Hi, it's a Shane over
Shane,
here.
Oh,
Sorry. Is this person a glober?
Yeah.
Yes.
Well, what say this person about this mathematics?
Yeah, I just posted in the live stream voice.
Mm-hmm.
Is this like
Oh, did I have that math wrong? Hold on. I'm just looking at the math. I haven't even looked at the results yet.
So remember, this is a horizon test.
Oh, see, I see. Okay, I can do that to do the side angle.
Well, the problem is the mountains have other mountains in front of them. Like if you're talking about any of the mountains you can see at 255 miles, for example, they have a whole bunch of other giant mountains in front of them. So you've got issues when it comes to specifically how much you can see. So luckily we have that beautiful giant body of water in between, and we can just test for that geometric horizon that would have to be there at 125 miles.
So 128.52 from the observer at just typical refraction. So if we do K0,
That's not even typical refraction. Typical refraction that surveyors use is 0.13.
yeah, so we can do that one too. 0.13.
Yeah.
So standard refraction.
Mm-hmm.
I mean, surveyors typically wouldn't use it at that distance though, but that's fine.
Well, surveyors wouldn't do an observation over this distance.
Let me find a way that I can share this. That's zoom out.
That's fair enough. I'm just making an observation that, like, with the longer wave of infrared versus the visible light, um, you know, basically there's less of an opportunity for refractive conditions. Not saying refraction can't occur.
Yeah,
You know,
I
there's
get you.
opportunity for refraction to occur in infrared more than other conditions as well, just based on if the conditions were right for infrared to be refracted. Like they did that with all the military laser tests. Or at least that's what I would do if I was in the military testing for refraction. You want to see all forms of refraction.
Mm-hmm.
But yeah, like I'm not a flat earther because I don't want to believe the globe. It's just like the more I dig into the globe, the more I find the devils in the details.
It sure is. How much do you guys delve into the physics around here?
So I got papers here that basically just say that standard refraction is just complete horseshit, basically. And not just because they're saying it, because they tested it over and over and over and over again, and it's just not accurate at all. So for anyone to say that just add standard refraction in, it's just I mean all it is just trying to flatten that globe out a little bit more. And it's not based on what would actually be happening over the distance at the time. Flat board, just due to refraction. And I don't think that there's any evidence that that's possible. But we can replicate all of the other uh, atmospheric refraction effects that we do see in reality that we can reproduce on a flat surface, like sinking, stooping, towering, which is stretching and compression and all that kind of thing, but not flattening out a curved surface by a huge amount. It's not. It's not able to be done.
What's a huge amount? Let's define huge, and maybe that will help us.
All right, so let's give an example of
10 miles.
just
Let's
because
say 10
I'm.
miles.
Let's say 20 miles because I know the
Okay,
math
20 works. Okay.
memorized. Right, so 20 miles is 266 feet of curvature. So that's like a 26-story building. So if I was standing on one side of a 20-mile lake and there was a 20-story building on the other side of the lake, I wouldn't be able to see it at all. And the horizon would be at 3 miles, right? Let's say I'm 6 foot tall. The horizon would be at 3 miles. Okay, so the additional 17 miles should be physically blocked behind the curvature of the Earth. Now, add temperature, pressure, humidity into the equation, and try to test it in some way that shows how you can get that 17 miles that should be hidden to just appear completely flat.
Sure.
And to
Let's do it
hide
right
that.
now. Okay, so what is the height of the observer on your 20-mile distance to let's say a 200-foot building?
Let me pull up an actual observation really quickly because I've got one over a 21-mile lake. That way we have visuals to work with. Sorry, just give me 1 second. All right, so this is the Great Salt Lake in Utah. 1 second. Here it is. So we have a 5-foot camera height.
5 foot?
Here's
Okay.
Yep. Here's a picture of the camera. So we got 21 miles distance, shoreline to shoreline, and we got a 5-foot camera height.
Okay.
And you just let me know what you need to see. If you want to do your own calculations. Right, so here's a picture of the distant shoreline that's on the other side of the lake.
Oh, 21 miles is what you said, right? Sorry, I need to update that.
Yep. 21, yep.
Okay. Great.
What's this calculator that you're using?
It's something I put together using some of the other calculators out there. I don't like how they take the globe and they like artificially curve it, right? So I wanted to make it so that the curve would actually be representative at scale. So like for instance, like the measurement we're doing now. I'll show you here.
It's pretty cool. I like it.
I'm giving it a shot to see what it's like before I say, hey, everybody, feel free to use this. I just built it like last night while we were talking through stuff. That was one of the reasons why I was on here for quite a while. I've been feeling sick, so I've got some time. But what I wanted to be able to do is, like all of them, like they'll show an artificial curve, and then they'll just throw like a lines across the top of the curve, almost like a tangent across it. But I'd rather say, okay, at scale. So the scale's down at the bottom. That is 621.37 miles for that scale.
We just need to fix the refraction coefficient to 0.13. 0.33.
That would be the 2/3 rule, right? Or the 1/3 rule?
No, that's not. No. 0.3 is considered like crazy heavy refraction. 0.13 is the
Oh,
standard.
yeah, I had that selected. My bad. That was based on the image I was doing earlier. But it has the other refractions on there. You see those? The other K values?
Oh, yeah.
Yeah. So that's the other thing that I really wanted to do too, is like every calculator I found had like you could put one K value and then you could see that K value, right? With this, I was like, well, why can't I just put multiple?
Do you have negative K values as well? Because negative K would actually is what what seems to be the case most of the time.
Yeah, I mean, I could. I'd have to find
But
some information about negative K values. I mean, they definitely make sense. I mean, you could just do it. I could just add them, but I don't know if they're representative of anything that I've seen.
Well,
yeah,
if you've
yeah,
only got positive K, that means you're indicating that light can only bend in one direction. We know that
right.
light can bend up and down, so therefore you have to have the availability. K.
Right, so I'm going to just bring up a citation from a paper from the National Journal of Geophysics. 1 second. Right, and they actually did their own tests, a stack of tests. And it says here, so this is the Journal of Geophysical Research, volume 115.
Mhm.
Upward refraction as a normal condition. The study confirms that upward refraction, negative K, is a standard occurrence during daylight hours rather
Did you
than
post
an
it or you?
anomaly. Yeah. hmm
Where did you post it?
I'm just copying the link now.
Okay. Oh, sorry. Here.
We have another researcher called Dr. John D, who's actually done a stack of his own tests, and he actually, because this is saying that during the daytime, it's mostly fluctuating between -1, right? K equals little k equals -1 and -3. Um, but at nighttime, Dr. John D is actually finding even more upward bending of the lasers. So yeah, it seems that the reason we never see lasers bending down is because upward negative K, well, if the Earth was a globe, negative K would be the normal. Because little k, right, that presupposes the Earth's a globe in the first place.
Action 0.13. Jeez. Magnitudes, is it? Let me zoom in a little bit. Those numbers look crazy. On the other hand, our empirical research results show us that the refraction coefficient K may reach magnitudes as high as +12 to +16 over grassland. That's crazy. Let's see. First time. Regions.
Yeah, that's +12, not -12. You require negative to bend down around your side.
No, the question we had was you guys were showing me a negative K.
Negatives is bending down. That's what you require.
No, positives bending down.
Yep.
Why the fuck would they run it backwards? Like, seriously?
Yeah, it's pretty weird.
Yeah, if you talk to Drace about that, he'll say how he's got some interesting papers on that as well. How they invert everything on the globe, but I don't know enough about that to repeat what he said. But that guy knows so much about this. Where did you get that 0.5 refraction coefficient is an inversion?
Oh, let's see if I can cite my source on that.
Look, don't worry about that. All right, don't worry about the negative k. Let's just get back to the
Okay, I'm doing two things. I'm reading the conclusion of the thing that you posted from Wiley Publishing.
Hey, it's a good paper. Maybe just take the time to read it, like later or something, because there's lots of interesting stuff in it. Um, Remember, they do assume, they do presuppose that the Earth's a globe, so take that into account too. But back to
And they
the
do
the
mention in
20.
that paper that they mentioned the exemption, that the odd man out being the Schofield and Breach at a K of negative 2.3 to 3.5 over ice at plus 14.9. What's that number mean? I'm trying to find their conclusion about using the negative K.
Hmm. Well, I mean, I read that's what the citation I gave said. It
Yeah, I'm
said,
reading that.
yeah, it says the study confirms that upward refraction, negative K, is a standard occurrence during daylight hours rather than an anomaly, which most people think it's an anomaly. But it's not. It's the normal. Because temperature controls the refractive index mostly, and the standard lapse rate is that it gets colder as you go upward. It's also more humid down lower, which all further reduces the refractive index down lower.
What page does it have the study confirms?
I'm not sure. I just had.
That'd be I've not too many research papers do I hear someone say this study confirms. I don't see it in the text, but it might be a error of the search.
Hmm. I'm not sure. I just had this saved in my
Yeah. Okay. Yeah.
in my
Yeah. Well,
server, so
you're right. Let's
I'll,
not dwell
I'll
on that.
continue to.
I'll keep looking. 'Cause I don't see them making that statement here, and in their conclusion, they're saying that there is an exception, which was one person's research.
Right. The point is, we get very varying numbers, right? So to claim that 0.13 could be accounted for, right? If you were to say that, let's just punch in 0.13, that would be completely inaccurate, basically.
I mean, it's not completely inaccurate. It's kind of like, I mean, but yeah, the
Well,
standard
it's not